Mm, okay, I want to talk about an abstract class. Let's see, we will discuss basic abstraction and mm, mostly uh, stream insertables actually. Draw, I guess, X call draw. Yep, cool. So let's see. So what I'm trying to do is let's understand something. I have some code written already. So what I'm trying to do, let's say I want to make 100 classes, and what I will do is obviously I might want to print them also on the console when I am trying to just doing like something like this. Okay, let's see. If I'm, let's say my class name is box container and I have an object named box container like this. Okay, so I want to do something like this directly, and I don't want to do the implementations on the main file. Okay, plus which is encapsulated behind the class. Okay, and I also want to do some abstraction. What kind of abstraction? Let's we will talk about. See, so I have a simple this here folder called abstractions, and I have two files and in which is named a class like stream insertable. So what I will do is basically make an hierarchy. Okay, so let's do this. So let's make a circle and we will add text in here. So which is, okay bro, this is so small. Font size XL. Okay, still not big enough. What the fuck? Okay, we can make this bigger. Yep. So an abstract class. So we have an abstract class here which is essentially named stream insertable. Okay, stream insertable. I don't know why it's like this, but it is, I guess. Okay, so I don't like this, but let's see, let's make it happen. So your stream insertable class, class name stream insertable, and yeah, what we will do is form an hierarchy. So every single class which we want to be printed on console directly, as I told, can we duplicate this? Okay, this is cool. This works everywhere, fine. So abstract class, so this will be, let's say, named box container class, container class. Let's see, we also have another class. Let's duplicate this also. Some class, let's say some sound synthesizer. Let's say it's interesting, sound synth. So we have two classes, we want to print them directly, so we would not want to what we say, duplicate code. So we will make an abstract class and inherit from the abstract class, which is essentially named essentially named stream insertable. Okay, so let's see the code now. We have these classes which are abstract, and we know that to make a class abstract, we at least need a polymorphic function which is marked by virtual, and it should be equal to 0. This is a syntax to mark the class as abstract. So if any class which has at least one abstract function, the entire class will be marked as abstract. Okay, cool. So let's move further down. So let's dig it in. So we have a function which is essentially virtual void stream insert. So we have a function stream insert. So what we are doing is we are just making the base strong. Okay, so we are just making the base strong in the sense, let's see. So we have this base, cool, here it is. So we are writing the base implementation, basically those two files but the implementation for each class will be provided on its own. Okay, so because implementation, okay, I don't know the spelling, but let's go here and add this here. So implementation, let's say this has two memory variables. Okay, I'm not very fond of this Scala draw, but okay, why control doesn't zooms out, I don't know. Okay, this is the minimum zoom. I'm at the minimum zoom. I get it now. So let's reduce the size, okay, and increase the zoom to, let's say, the 100%. Gotcha. Yep, so this is fine, and let's wait a second. Yeah, so we will duplicate this, and let's say we have two memory variables, which is side and width. Let's say we don't know the implementation of the box class, but let's just do this. So let's say we have the implementation like this, something like this. Cool. And similarly we have then okay, we have an implementation of sound synth. So let's say sine wave and decibel, or something like decibel, something like this. So we have these two classes with their own implementations. Okay, cool. But we can't just generalize what we want to print on the console. So we have the object with us, but we just can't simply generalize what we want to print. Okay, so let that sink in. So the base implementation will be there, but the implementation for each class we have to define for the each class, which will be inherited from this interface, which is stream insertable. So which essentially explains us that we need the function implementation for each class, which is exactly the concept of abstract classes. Okay, let's we have understood this exactly. So we made this function, which is an implementation which will be in the implementation will be defined for the each inherited class we are giving to it, which is cool. So we define this function, cool, but we need the overload also. So what we will do is, let's say we are defining this, we are not making an interface of abstract classes. Let's say we have the sound synth class itself, and we are making an stream insertable proprietary for the sound synth class. So what we would have doing, okay, what would have we be doing is, let's duplicate this here. Okay, here. So what we would do is simply make an overload. And what's good about this, that this is very easy to implement, because we essentially know the current object, cool, which is this is the current object. This is a pointer which points to the current object. Okay, and we know the current object, and we know the member variables, and we just need to print them. So the implementation for this, for the overload, what is the implementation for the overload here? That we know what to print, we know the address of the object, cool, we know everything, we just need to print it. Okay, So print it. Cool. So this is what we would have done if it was not an interface, but now we have an interface. So what we will do is, see, we will make an implementation of the stream insertable function here. So this is not a public member function of this interface, but this is a standalone function. Why? That is, yeah, so it should be standalone function. There is nothing, we can also make it a public function, but making it a standalone function gives us more liberty, which is not a big deal, but let's see. So this is obviously returning the OStream back as a reference. So we don't have tools to understand this, but obvious, this is kind of intuitive that we need to return a reference of the stream, but not a by value. So we don't want to make a copy of this stream. This is kind of obvious, okay? But so we are returning the reference of the OStream, but what is that reference? We are also accepting that reference to use that reference. Okay, fine, never mind. So we will get this. So we are returning this OStream for chaining purposes. Which essentially means that we accepted we accepted OStream cool, and what we will do is we accepted the OStream and we will return the OStream again. Okay, and between that we will use that shit. Cool, but we need to chain this. So we are returning this because we need to chain this. So we will, if we do this container or synth endl. So to do something like this, we need to essentially chain this bullshit. Okay, this is fine, we get this essentially. So what we are doing is, as we knew with this analogy, that we need the implementation of the overload essentially, and the implementation of the overload is what we know. We print it on the screen. Let's see, we have 5 member variables. We will print the 5 member variables one line by line on the screen to get the information. So what is the implementation here? What is the implementation of this operator overload? Operator overload is this stream insert, which we essentially define here. This is cool, isn't it? So why we are accepting out? Why we are accepting out here? Why we are accepting the OStream here? Because when we will implement something, implement the implementation of the stream insert public member variable, we are also required to return it, don't we? We will also return that, or let's okay, we don't even have to return that because we are returning it here. Essentially the overload is returning, we don't have to return anything here, but we need to use the out to print, because the implementation contains printing into the stream out stream. We need this to obvious. This is kind of obvious, isn't it? Cool. So we have this virtual function which makes this class abstract. We have this function which is overload to the operator, this operator, and this essentially calls the implementation of this, which will be decided in the inherited classes. This is cool, is it? And obviously we are befriending this in our class so that this can be called directly. This is obvious. And now let's go to our box container class. There is no implementations for this, but let's do something like this. We will paste this override. We can also make it override actually. Let's be real. Const override, because we don't want any typos essentially. So I don't know why it's okay. So because we never inherited from this the stream insertable interface, and we need to also call that. We can also call the call forward way, which does not bring all the implementations but stream insertable. Let's not do that here. Include slash I have never done something like this, but let's see. Slash abstractions slash okay stream insertable dot h, and remove this. Yep, this works. See, this works. And we have the stream insertable interface, and we have the implementation here. So what is the implementation? Let's make some private variables and make this function public, member function public. Obviously we need to use this all the time. And let's make an integer of size. Let's say let's say width. Okay, cool. So what we need to do is use the out and this dot width. We don't even we are not even required to use this. We can just simply print the width, because okay, yeah. So this is cool, isn't it? This is cool. So now we can directly build an box container object and use the stream insert. This is something which I wrote for. Okay, so let's make an box container and include this box container here. Include this box container here, box container dot h, and we will make an object. Because it is marked as const also, we don't have to worry about a const object also. So let's make the const object box container and box one, let's say box, and just build this. So what we have to put it here, put width here. Let's initialize with the width. Okay, but we don't even have a constructor for this. Shit, so we also need to build a constructor. That's bad. Let's build make the implementation box container. I'm not dividing the implementation here and there. Okay, so I'm just doing the initializer list method of building a constructor, which is width. Is essentially what we have, what we are receiving from the constructor. So it is an integer which is width, and width parameter, and the member function will be equal to the parameter of the width we are passing to this. So this is a simple initializer. I'm not separating the implementation to the implementation file, which I should have done, but let's not go there. Okay, and we will use namespaces and bring the namespace std here, so that we can use this cow directly and print the box. This should work. I guess this should work. I don't know why it's not working, but conversion to accessible. Okay, so by very basic figuring out, okay, I just found that we were inheriting privately. We have to obviously publicly inherit the stream insertable, and we can just then simply print this. There is no issue, I guess. Okay, so we can just compile the file and run it. It is showing 10 because we can just directly print the box using the abstract interface we created. This is damn cool, bro. Like, it is fine.